In this video, I just wanted to show you the results of my playing around with the Unihiker device that you can see here. Just wanted to try a few very simple things just to become a bit more familiar with both the hardware that comes with the Unihiker on board, things such as its connectors and its onboard sensors, plus the Python libraries that are also developed by DevRobot just to make it easier to access those devices and the various hardware components that make up the Unihiker. So I have spent about an hour and a half earlier this morning to develop a very simple demo application that takes input from the gyroscope and the accelerometer, and of course it uses the screen to display out some of the values that come out of the accelerometer and the gyro device. And also wanted to try out accessing and controlling an LED via the ports, again using the touch screen that you can see here. And it turns out that it is quite simple to do that. I'm going to show you two ways by which you can write Python scripts and access all of those built-in features in this video. So I'm going to show you, I'm going to start. So here, I'm starting from the end really. I'm just going to show you what we're going to get to by the end of this video. And the end result is this very simple Python script that takes readings from the accelerometer, which is somewhere here. I think it's this device here. This chip right here is the accelerometer and gyroscope. Takes readings out of that, and it displays some of the values that come out. In this case, I've got the accelerometer X, Y, and Z values. I haven't printed out the gyroscope values, and I'm also depicting those values graphically. So the red is the accelerometer X, green accelerometer Y, and the blue is the accelerometer Z value. And I've multiplied by I think a couple of hundred. We'll have a look at the code in a moment just to make the lines look nice. And down here I've got a button. So when you press this button, just use my tool here, you can see that the LED goes off and on again, or you can use my finger to do that same. This is I think a capacitive screen, so it does not allow multi-touch, but one simple tap works quite fine. You can see if I use my picker tool here that a kind of arrow appears on the screen. I'm not sure if you are able to see that. A little arrow that shows that this is basically a cursor that produces the click. All right, so let's now take a few steps back and have a look at how this whole thing works. I've got an introductory blog post on the Unihiker, so I'm not going to go back to the very beginning. So I assume that you have had a look at that blog post, or at least you kind of know what the Unihiker is. Documentation for this device is available here on the unihiker.com website on the wiki. You can find pretty much everything there is to know about this device. And here on this video, I'm focusing on these two Python libraries, the Ping-Pong library and Unihiker library. The Ping-Pong library that is documented here gives us Python API access to the onboard devices. For example, with this library, you can access the LED that is right here, and that's on GPIO port 25. There's a light sensor, the accelerometer, and the gyroscope that I'm playing around in this set of examples. There's a buzzer and a few other things. So that's what this library is about. And then there is also the Unihiker library. And this library, I'm just going to have a look at the introduction. And this library allows us to access other parts of the device, such as the screen in particular, and contains functions to allow us to do things such as write text on the screen, draw basic shapes, and read input from a mouse and a keyboard. There's also multi-threading that looks very interesting that I haven't tested yet, but that is something that I want to have a closer look at a later time. All right, so this is where to look for documentation. I might come back to this a bit later. So let's have a look at how we can use Python to program on the Unihiker. So here I have connected my Unihiker. This cable here is just providing power. It's not connected directly to my computer. And previously I've just set up my Unihiker, so it's accessing my local Wi-Fi network, the same network that my computer is connected to. And I'm now able to access this device via my web browser. And here's the address. When you access the Unihiker web page, you see this homepage, and you go to the service toggle. Make sure that Jupyter is started through the Jupyter service. I'll be using the Jupyter service for most of my programming here. And then just click on Open Page. That will take you to the Jupyter homepage. Now from here, you've got a couple of options when it comes to writing Python programs on the Unihiker. The first option is to go to the new menu here, expand it, and then open up the terminal. And it gives you terminal access. And from here, you can browse the file system. There you go. You are logged in as root, so be careful with that extra power. And here I have created a directory called Python scripts that contains some example scripts. Also, before I go into Python scripts, just notice that I've got a few files here with the IPYNB extension. These are Jupyter files, so you can see the led.ipynb. This is one of my Jupyter notebooks, and there may be another one here, but anyway, this is where these files are stored. So here's another one. Draw Unihiker. This is one of my other programs, and it's in quotes because it's a space right there. And there's a couple of other files up here. And if you go back to the Jupyter homepage, you'll see that these same files, so here's accelerometer and gyroscope with screen output, accelerometer and gyroscope, draw, Unihiker, and LED, all of those with the IPYNB extension, and you'll see those files stored here at the root directory of the root user. So let's go inside my Python scripts, and in here I'm just going to clear up, and in here you'll see a few scripts that I've created earlier, including led.py. So the first thing I'll do before I run this very simple program is to just stop the execution of the program that is already running. And then I can go back to the terminal. First, have a look at this program, led.py. Very simple. Import time, import the appropriate modules from ping-pong.board. So that's the Python library that we're using to access the LED. Then board begin, then set up the LED object that allows us to control the LED connected on pin 21. And then inside the infinite loop, I turn on the LED, print a little message, wait for a second, and then turn it off, print another message, and wait for another second. And I can run this program using the Python interpreter, so led.py. So there's the LED connected to one of the ports. It's probably not going to come through on the video, but right here on this port you can see that this pin here is marked as pin 21, and that's the pin that I've connected to the anode of the LED. And then the other pin goes to ground, that's marked with a minus symbol here. I also mentioned that there is an onboard LED, and I just use Nano to edit this script and just change 21 to, I believe it's 25. So let's change this to 25, save and exit, and run the same program again. And there's the blue LED That's this sensor can be controlled via GPIO 25. Okay, that's cool. So Control C to exit. And I've got other programs here. Let's have a look, for example, at the accelerometer. So clear, cut, accel.py. Very simple. This one again uses ping pong board, and then the extension of the Unihiker imports everything. So this is the Unihiker library, because this gives us access to the accelerometer device, so it can read X, Y, and Z, strength, and then the gyroscope. So again, this works with Python and excel.py, and there's the values coming out of it, and I can then just cause these values to change by moving the Unihiker around. Very cool. So that's one way to program the Unihiker using the command line and the terminal. And I've got other programs here as well, but I'm not going to worry about them for now, especially the accelerometer GUI. Now I want to show you the other way to do this, and that is to use Jupyter notebooks directly. So remember the LED program that we saw earlier here in the terminal? You can do the exact same thing via Jupyter. Now, if you're not familiar with Jupyter, like myself, I only know very basic features that it provides, just enough to allow me to play around with the Unihiker. But I do recommend that you take a few minutes to have a closer look at what Jupyter is and what it can do. But for now, it's enough to know that it is a web-based interactive development environment for notebooks, code, and data. This is a web-based programming tool. I'm going to double click on this document here to bring it up and have a look at what this program that we earlier saw on the terminal looks like inside a Jupyter notebook. So it looks like this. You've got these fields where you can enter code. I can just take this code, for example. I'll just copy it, paste it here, and there's your code that you can execute by clicking on the run button. I'm going to remove this. Or you can do other things, such as, for example, you can write Markdown and write some documentation. Here is some documentation, and you can use Markdown language to provide some text formatting if you want. You can combine code with other types of text here, in this case Markdown text, and you can see what else is available up here as well. Anyway, most important thing right now is the code. So you can see I've got the same program as I used earlier. I'm using pin 21 here, and I've got the same outputs. So I'm just going to click on the run button, and you can see that the LED is blinking on and off, just like it did previous version of this example when I used the terminal. So I'm going to stop it. And I'm going to show you then something more interesting, I believe. So what I wanted to test next and learn about with the Unihiker was how to use the screen, which is obviously a major feature of this device. I want to use the screen to get information from its onboard sensors, and then to also use it to visualize that information. So I've got text and like text up here and some graphical visualization of the X and Y and Z accelerometer values. Plus, I wanted to use it as input. So I've set up a simple button that when I press, I can control this external LED. So let's have a look at this first as it's operating. So I'm going to click on this button here to restart the Python kernel. So click on that. It's restarting the back. You can see that the screen, that the user interface that this sample Python script created disappeared, and it went back to essentially the operating system. Just going to tap on back. There you go. So it starts from scratch essentially. like that. And I've got a little bit of documentation here in my Jupyter notebook. And here's my program that I'm going to go through in a moment. And I'm going to click on Run. And you can see the output coming through. Oops, so I need to use exit. Okay, let's try again. I'm going to click on the stop button. And then run again. Okay, so that's working. And as I'm moving the device around, you can see that the bars that represent the output of the accelerometer device are updated. The LED is on when the program starts, so I'm just going to tap on the button to turn it off, and then on again, and so on. Very nice. So let's have a quick look at the program again. So up on the header, we import the necessary libraries. So there's time to keep track of time, board. This gives us access to things such as the LED, Unihiker, so we can control the screen, and then the GUI module of the Unihiker library, so we can draw things on the screen. Then we create the GUI object, start the board. Here I set up the LED state variable, set the button color to red so that we can set up the color to begin with. This will be alternating between red and black. Set up the LED object to control the external LED and write 1 to the LED to turn it on. So that's how we know that the program has started. Then I've got the toggle LED function that will be called when the button is pressed. So I'm going to jump all the way down to this line right here, where I create the filled rectangle with rounded corners. That is this button down the bottom of the screen. I set its dimensions and position and its color. Its color changes depending on the state of the LED. You can see the if statement here. And then I've got the handler of what should happen when the button is clicked. So there's an event handler here on click, and I've got the name of the function toggle LED. And if you go to the documentation and have a look at this particular function, let's go to basic shapes. I believe it's in here. So basic shapes, filled rounded rectangle, and you can get some more insight as to how this works. And all of those widgets and shapes are very similar in the way that their functions work. So I'm using pretty much the same parameters for all of them, which have to do with the position, the size, and colors, and things of that sort. So that's what happens down here. Let's go back up to the middle of the function. We already talked about toggle LED, and then we go into the infinite loop. We take measurements from the accelerometer and the gyroscope. I've commented out all the printouts just to make this output a little bit smaller. And I noticed that as this output part of the notebook was getting filled with text, the application, the execution of the script was getting a bit slower. So I decided to just comment out those lines in order to not degrade performance. So then we use the various functions such as fill rectangle and draw text. To draw a rectangle, you can see here I've got a rectangle with a red background, and on top of it I've got some text, this text here, plus the stringified version of the floating point number that comes out of the accelerometer right here in white, whereas the rectangle itself is in red. You can see the red color there. This kind of green, and then finally I've got blue, and the same information. The only thing that are changed are the pixel dimensions and positions, and the text that is contained and printed out. So down here on line 48, I'm drawing a white rectangle, and that's simply to clear this part of the display so that a new set of lines can be drawn without overriding previous lines and making a mess of that part of the screen. So clean up with white and then draw the lines for the X accelerometer value, Y accelerometer value, and finally the last one. And because the values that are coming out of the accelerometer X, Y, and Z are pretty small compared to how many pixels are available on this screen in the X dimension, I multiply here by 100 just to make those lines a little bit longer. So that's it with drawing the X, Y, Z accelerometer lines. And then finally here on lines 59 to 62, the code simply checks the state of the LED, whether it's on or off. The state of the LED is kept up here in toggle LED, and notice that I'm using the global keyword to ensure that this function can actually rewrite the value stored in the LED state global variable. Without it, it wouldn't be possible to change its value from inside this function. So down here, checking the value stored in LED state and then choosing the appropriate color, which is then used as background for the filled rectangle with rounded corners. After playing around with the Unihiker this morning and doing a little bit of reading, I'm now inclined to do some more with it, spend a little bit more time. I particularly want to investigate the multi-threading capabilities and see what this is like, because the microprocessor that is running the Unihiker device on which the device is based has multiple cores, so I want to see what is possible to do with this. I'm going to play around with this a little bit later. I'm going to also spend a bit more time to investigate some of the other onboard features and capabilities, things such as the speaker. I'll connect the keyboard later on and a mouse and see if I can actually use the mouse to click on things that are on the screen, and I'll be able to see the cursor perhaps, just like I can with a regular computer screen. Let me know if there's something specific that you'd like me to look at and investigate. And apart from that, I'll be back with more Unihiker experiments.